So chapter 11 deals with systems and matrices. In this chapter, I'm going to remind you how to do systems of equations, how to solve them, how to graph them, how to do elimination and substitution method. And then we're also going to talk about matrices, which are other ways of solving the systems of equations. We begin with the definition of what a system of equation is. As you can see over here, there are problems with two equations that have x and y. This is what we call a system of two equations with two unknowns. So there are two equations, and usually the brace just tells me that they are together in the same problem. And that's what we call a system. And normally, the very first thing we're going to do is figure out what the solutions are. So in other terms, we're going to look for what numbers make the first equation and the second equation true at the same time. So in this first problem, we're going to learn how to check if the pair that we got is a good or not answer. So is it good or is it not a good answer? So normally you want to remember that the x is always the first number and y is the second number. So what you're going to do is test it out by plugging the numbers into each of the equations. So we have two equations. We're going to plug the x into the first equation, and we're going to plug it again into the second equation. We're going to do the same thing with the y. We're going to plug it into the first equation and again into the second equation. And what we're hoping to see is that both equations end up being true. So is it really true that 3 plus 1 equals 4? Yes, this is exactly true. What about 3 minus 1? Is that really equal to 2? Yes, this is true. So what does that mean? That means that 3, 1 is a solution of that system. So this gives us a way or a method to discover whether a pair is a solution or not. And so to be called a solution, your pair has to make both equations true. If one of the equations fails and it's false, then you can stop and say that the pair that I have is not going to work for this problem. So let's test out the second pair. The second pair has 0 and 4. So again, the x is 0 and again, the y is 4. So let's plug it into the first equation and let's plug it into the second equation and see if the pair works for both of those equations. So the first equation has negative x plus 2 times y. So I'm going to plug in the x and plug in the y and see if that turns out to be 8. And then again, I'm going to do the same thing with the second equation and see if the answer turns out to be negative 10. So the x is 0 for both of them and the y is 4 for both of them. And let's test it out. So the first one says 2 times 4 is 8, which is true. So that's a good thing. So far, it's good news for the 0 and 4. It seems like it's going to work, but let's wait and see what happens with the second one. Here, 2 times 0 is going to be 0. 2 times negative 2 times 4 is going to be negative 8. Is it really true that negative 8 equals negative 10? The answer is no. This is false. So because it's false, I'm going to say that 0, 4 is not a solution of this problem. So unfortunately for this problem, the answer is that 0, 4 does not work. It is not a solution of the given system. So I'm gonna go ahead and give you a chance to pause the video and try the last one real quick, and I'll tell you whether it's true or not in a second. So go ahead and plug in the values x equal to negative 2 and y equal to 3 into the system and see if they work for both equations. So it turns out for me that the answer is true for the first equation and true for the second equation. So it seems like the pair that they provided me is the right answer. So what we're going to be doing in this chapter is pretty much discovering how to find the pair. So what we're going to be doing over the next few pages is methods for discovering the numbers.